keer proberen.
Dat iets.
Normaal als hij hier zegt live, zendt hij live uit, dus ik snap hem. Nu is hij, heeft hij weer van dat SD-kaartje, ofwel is het van dat SD-kaartje. Wat daarmee te maken hebben? Ah, het is in orde.
Oké.
Ja, oké. Het staat allemaal op. Het geluid werkt dus ook. Dat is dus de midden dat je dat 3 kan daaruit krijgen. Oh nee.
Stel als conversatie die ook gezien.
Nou, dat wij nu gezegd hebben, de micro staat nu heel dicht bij de micro. Staat er nu ook allemaal op, wat ik nu vertel. Staat allemaal op. Het geluid werkt dus ook. Ja. Voilà, ik ga belachelijke dingen zeggen.
De volgende week.
Ja, van de week structureren, de eerste les. Ja.
Dan moet je vergelijken met elkaar terug bij je.
Het is terug mee, ja.
Of letten door dat vergelijken met elkaar?
Nee. Nee. Er is meer blokwerk, meer studeerwerk. En ja, minder oefenen, zeg maar. Denk ik. Ja, minder oefenen. Het zijn andere soorten oefeningen. Ja. Voordeel is wel dat er een volledig uitgeschreven Nederlandse talige cursus is. Die overeenkomt met de Engelstalige slides. Dus die kan je afdrukken en kun je gewoon uit het boek studeren. Dat is wel het voordeel. Omdat er juist zoveel theorie in zit eigenlijk. Dat is een beetje uitgelegd. Dus. En meestal zijn de slaagcijfers daar ook heel goed. Ja. In vergelijking met bijvoorbeeld aan scripting is dat typisch lager.
Ja, maar mijn ouders was echt.
Want dat is meegevallen in van en dat er maar 2 geslaagd waren, dus vergelijking met het niet. Ja. Beetje vergelijkbaar met dat. Dat is de andere week.
Ik had daar zo een idee bij, waken, maar ik had wel te weinig tijd. Maar dan is het wel een ik had zo niet alles 100% afgewerkt van de laatste. Dat lag precies zo
Nee,
aan mij.
je was er toch? Ja.
Ik had ook wel, ik heb iedere keer gevlucht. Al die dingen.
Ja, dat probeer ik ook wel, omdat soms hele hoge scores en bij ons is tijd ook wel een belangrijke factor.
Ja, want op het moment dat ik dus eigenlijk na hetzelfde moment vergeet niet naar alle oefeningen te kijken. En ik had juist 5 minuten gehoord, dacht ik, oh nee, ik moet die laatste oefening ook nog doen, dan ga ik echt niet lukken.
Ja. Dat is het, probeer zoveel mogelijk punten te verzamelen, of dingen af te werken en soms niet op eens te blijven zoeken voor een half uur.
Ja,
Dan kun je een half uur dan voor iets anders gebruiken. Dat is heel, zeker voor scripting gaat dat belangrijk zijn.
ja.
Dan moet je, kunnen we geen 10 oefeningen geven, dus zijn meestal 2, 3 scripts die je moet schrijven. Dan is het belangrijk dat je probeert zoveel mogelijk en niet tot in de details.
Schatting is dat volgend jaar?
Dat zal het eerste vak zijn in september, dat is ook voor mij.
Wordt er nog voor het eind van het semester nog iets over de stages en zo gesproken?
Dan ga ik hier een andere stagecoördinator vragen, wat hij dan nog gaat. Ik denk
was
enkel
dat
voor als je
misschien
interesse hebt en je heeft hij nog niks voor de internationale stages. Ik dacht dat er daarover iets gecommuniceerd wordt.
Ik heb ook onlangs een gesprek gehad op het werk, waarom ik ook begonnen met ja, we zoeken naar iets stage. Dus die op bedrijf.
Ik ging net zeggen, 9 op de 10 doet het gewoon waar ze werken.
Ja, want
Dus
als je dan van dat team of naar waar moet op zoek.
Ja,
dat weet ik eigenlijk
wel
wel
niet.
niet.
Maar als je eventueel het eerste semester daar al mee kunnen beginnen, want ja.
Ik ga dat doorgeven dat er eventueel een mening of zo is.
Dus vooral stel dat het niet op mijn werk kan, dan moet ik daar wel echt een keer over nadenken. Qua verloop, want ik heb geen educatief verloop meer. Dan heb je snel doen.
Ja.
Ik heb zelfs zoveel verloop niet. Om een stage te doen.
Ja, 300 euro is veel.
En het is niet bijvoorbeeld dat je zegt van ik kan voor mijn werk een project doen, maar dan ergens anders, is dat mogelijk? Je zegt van ik kan wel data analyseren of een project voor mijn werk, maar ik kan daar niet begeleid worden.
Mijn klinisch bioloog werkt ook nog ergens anders. En zij, als je daar kunt gaan, daar zou ik nog wel iets kunnen bijleren voor hier. En dan kan ik ervan antwoorden dat u tegemoet kan komen in opleidingsuren.
Ja.
Maar ja, dat is nog wel weer een beetje op hun voorwaarden ook. En daarmee ja, kunnen ze niet wachten tot het laatste moment. Ik denk dat dan voor jullie moet weten, moet je er ook wel een keer over nadenken wat je gaat doen.
Ja.
Of onbetaald verlof of zo, maar ik weet niet hoe werk ik dat van voorhand doen.
Dan wil je meestal wel wat voorhand vragen.
Ja.
Ik heb nog zo'n 2 jaar
Het zijn ja, het is 295 uur is stage, dus het is als we over voor nieuwjaar, 8 jaar, nieuwjaar, het over handjaar kan spelen. Ja.
We gaan er nog niet gewoon over hebben. Ik gebruik ook wel weer verloffen die bakken.
Kijk, ik zal het doorgeven en misschien volgende week weet ik dan al halen. Ja.
Dat is ook nu is dat superleuk.
Voor mij is dat voor mensen dat ik bij de overheid zit. Dus ik weet niet wat dat zit. Dus daar heb ik geen recht.
Nou, waarschijnlijk is het nog te duur.
Ja, nee. Dat ik daar kan ik eigenlijk niet bij het tweede systeem.
En dat is ook zo heel licht.
Nee, zo. Ik weet niet. Niet van de overheid van de ja, dat is ook goed. Ook al van volgens mij. Maar dan moet ik kunnen aantonen dat voor mijn werk is informatie valt. Het is niet wat ik zie gaan proberen op de werk moet doen. Ik had al een vraag gegeven bij de maatschappij, zodat eventueel misschien ook wat er in de gemeente met de job is.
Bij mij waren we nooit van, ja, mocht ik in de korte vlog was heel technische door.
Ik had gevraagd samen aan plaats. Gewoon aan de personeelsdienst binnen.
Ja, ik heb mijn blad al binnen gedaan, maar ook daar alles doorweg van.
Tegen mijn baas als je niet meer en hoe goed je daar kunt stellen. Dat is echt mensen. Ik heb me dan gevraagd en die had dan opgepakt.
Bij mij, we moesten online spelen. En wat kan worden als we studeren of ja, gesprek, die validatie is een gesprek. Nee, ook niet, maar ze wilden weten wat er in die groep leeft en wat er problemen zijn. En dan voel je duidelijk zijn, dan is het zo, zeg ja, dan gaan we nu gaan zoeken in een punt. Ik had het ook veel werkboeken, of dan gaan we één boeken, of dat steeds voor. Ja, en we gaan een keer moeten kijken voor de stage. En ik zeg, ja, ik begin nog eens met eerst jaar. En dan zullen we wel zien de volgende jaar voor die stage. Mag ik hem zo nog vaststellen voor de pakken?
Soms kan nog wat meer. Mijn baas moet dat ook niet doen. Nee, in theorie wel, maar dat is hetzelfde volgens mij. Dan de wegstellen, dan een verpleging bij deze student van.
Dus zo na het laatste examen al het van mij als en dat is niet juist, omdat ik zo niet om die relatie heb. Dat is de vraag van mij, van mezelf. Ja, nee, dat is het heel andere dan zo. Alleen zo weg met zo'n software en ook en zo wat
Ja, maar je ziet het van wat inderdaad.
Het is weer zoveel van vakken leren. Dat is niet meer zo veel.
Wel, ik kijk ook van doen, dus niet moet kijken dat er inderdaad ja. En dan, ik hoop dat het weer kan doen.
Okay, let's start. So today we're going to finish up the part about MySQL and talk some more about the NoSQL databases. We're going to touch the subject of online databases and their APIs. We'll finish the course with some version control. So in the previous lesson we've talked about the MySQL monitor but as a graphical user interface in the form of MySQL Workbench. And we talked about some data models and then we started with normalization in order to create our entity relationship diagram. And then we studied the forward and reverse engineering functions in MySQL. So of course our MySQL database is not a standalone part in our research. And more than often it's used or integrated with other programming languages. For example, PHP, if you want to make your database available through a web interface. There are some PHP extensions which you can use in order to translate your SQL code to PHP code. Some of the most known are the MySQLE extension and the PDO extension. They both work with MySQL and they have several means or ways of connecting. Some example code could look like this. So where in your PHP code you specify your credentials to connect with your database. You set up your connection with the MySQLE Connect, and then you can check if this connection worked or not. If it worked, just print this to your web page. If it didn't work, print the error why it didn't work. And in the same manner, you can execute queries inside your PHP code. So remember, first always connect, then, for example, create a database, do a query with the MySQL query, give it your connection, which you created before, and your SQL statement, and it will again prompt out a error message if it failed, and a success message if it worked. At the end of your page or at the end of your database actions, remember to close your connection, because otherwise your connection remains open until your web server dies. And MySQL can't handle too many open connections. The same examples go for insert queries, where you just specify your query again in your PHP code, like you would do in MySQL. You execute the query again, giving it your connection and your query. You can ask for your last inserted ID. This can come in handy if you're working with an auto-increment ID system, for example. And you can also prepare your statements. So if you would like to insert some data, you can always prepare a statement where you don't know the values up front. Then you can bind parameters to it. And for example, you can set them yourself, or you can get them through a form. get the values of the parameters, execute the prepared statement, like so, and it does the same as just inserting data in your database to a normal statement. Remember to close your prepared statement and of course close your connection. But more importantly, most of the time you will want to select data from your database. Well, this is just entering your select query, executing it with your connection and your query, check if it returns results, if your query is correct, so the number of rows returned should be more than 0, and if it's correct, you can do something with your data. Doesn't matter what. Here we just want to echo the ID and the name, one on every line. If it has 0 records, of course, you can always prompt another message to your screen. And then at the end, of course, remember to close your connection. This was the procedural style. Remember that there's also an object-oriented style. If you want to choose one of them, just choose the one you're most familiar with. This basically does all the same things as the procedural style, so you can also create databases, insert and select. If you want to know more in detail, there's plenty of information on the PHP website, but we'll not go over it here because this is not the PHP course, of course. And next to PHP, MySQL can also interact with Python, for example. Again, there are some readily made modules in Python for you to explore. The MySQL connector is one of them, or MySQL DB. Just remember to import them at the beginning of your code so you can use all its functionality. And then again, in both ways, it's just a matter of connecting to your database with the right credentials, creating a cursor on your database, giving it a query and executing a query, and of course, after you've finished your work on your data, remember to close the cursor and close your connection. Okay. And this brings us to the next part already of our lesson. And this is the NoSQL part. So far we've been working with relational databases. More specifically with MySQL. Now we're going to look more into detail to the NoSQL databases, and these are also database management systems, but as the name says, they're non-relational, which means they are quite more flexible than a MySQL system, for example, and they're often used for big data and real-time web applications, where you want to query your database really fast, or you don't have fixed queries beforehand. Some downsides of these systems could be that they lack atomicity, consistency, isolation, and durability. And what does this mean? Well, atomicity just means that a transaction should be carried out entirely or not carried out at all. So, for example, it returns your database to a normal state. Consistency means that after your transaction has been carried out, it must change data only in allowed ways. So any data written to the database must be valid according to the constraints you've given your tables, to the rules and any other options you have provided. Isolated means that typically this is defined as databases where you perform a transaction and the intermediate results of your transaction are not visible to other users. So, for example, if I'm updating my database and another user is querying the database at the same time, he will not see my updated results until after my transaction is entirely completed. And durable just means that transactions that have been committed to your database will survive permanently. So for example, if I enter something in my database, well, this will remain there even if my system crashes, because the state of my database is saved in my backups, of course. Inside these NoSQL systems, we have different categories. So, like we had our MySQL system in our relational databases, we now have column stores, key value stores, graph stores, multi-model store, and the document store version of a NoSQL system. And what do these mean? Well, the column store, for example, is the Cassandra system from Apache, which Facebook uses or has used quite a lot. And it's basically just, it consists of tuples containing 3 elements. A unique name for the database to get every unique value, then the values and a timestamp when your data point is created. So these tuples do not have to be in every row, and the number of columns can change from row to row, meaning that the structure of your database is not fixed as it was in a relational database. And as you will see, this is one of the perks of a NoSQL system that will come back in different subsystems. A key value store, for example, could be the Oracle NoSQL database, and here data is stored in a dictionary or a hash, which we know from programming languages, and it's just a collection of objects or records. Again, these objects or records can have different fields, but they should, of course, have one unique key per record in order for the database to recognize different records. It consists of a single collection, but different fields per record are possible, as I mentioned before, and it uses a lot less memory than other systems. Another example of a NoSQL system is the graph store. This system exists out of nodes, edges, and properties, where nodes represent entities, for example, people, let's say, and they are roughly the equivalent of a record, or a relation, or a row, as we know in relational databases. Edges, for example, are the relationships between these nodes. And properties are, of course, the property, as the name says, the properties of these nodes. So they contain specific information about these nodes. And the graph store is a module that is often used for simple and rapid data retrieval, and it has its own query language in the SparkQL language, that is. And the main purpose of these graph stores is to use shorter path queries. Like you would do in mathematics, you will also search for the shortest path with graph. An example of this is OrientDB. Another type is the multi-model. An example could be Couchbase, which uses both relational and document store models. And as the name says, the multi-model uses multiple data models against a single integrated backend. So all previously mentioned NoSQL models are supported. And then the last one we will mention is perhaps for us the most important one, is the document store, where data is stored in a semi-structured manner. And it's actually a subclass of the key value store. And why is it called document store? Well, because the internal structure of the database looks like documents, and these documents contain key value pairs. So all information for a given object will be stored in a single instance, and every stored object can be different from every other, like we've seen with other models. So no two records have to have the same structure. This system is often used for web applications, and documents are again identified by a unique key. And one of the main perks of this document store is that it supports CRUD operations, as we've seen with MySQL. So we can create, read, update, and delete data with our specific queries. The document store uses no predefined data formats. So you can change your type and your form for every record, and it does not have any effect on the database itself or on the existing records that are already in the database. It doesn't use any normalization, which is a major plus for most of us. And one of the most known examples is MongoDB, and this is a system we'll be exploring a bit further. So why have we chosen MongoDB? Well, some of the same reasons as for MySQL. It's free and open source, and it has a large community which supports it, so it's very easy to use. It uses JSON-like documents, and it supports ad hoc queries, meaning that it's very flexible to perform queries that you don't use that often, whereas in a MySQL system, you create views to facilitate this. As in MySQL, you can create indexes on your database as well, and it supports replication and load balancing through sharding. Well, what does this mean? Well, replication just means that you will have 2 or 3 instances of your database, and if the first one fails, your data is still in your other replicates of the database. So every replicate contains exactly the same data as the main instance of your data. The load balancing through sharding will happen when you divide your data over multiple instances in order to use less resources from one instance to obtain your results. MongoDB also comes with a integrated file storage system. So files smaller than 60 megabytes will be stored in the database itself. But MongoDB can also store files larger than 16 megabytes, and it uses a grid file system for this. As we've seen with our MySQL system, we can do some aggregation queries. But in MongoDB, the aggregation queries will be performed in the form of a map reduce. So coming back to the JSON format, which MongoDB uses, well, JSON actually stands for JavaScript Object Notation. This is a data interchange format, which is quite easy to parse and to generate, and it's used in many programming languages. And it consists out of objects and arrays. So one JSON object could look like this, where you have your entire object between curly brackets, and then it has key value pairs, or again, other objects, or arrays. That's it. But we'll come back on that later. If you want to install the Mongo server on your system, you can just follow one of the tutorials on the MongoDB website. And if you've done so, you should be able to start your server or your Mongo server with one of these commands. So it's basically the same as with our MySQL server. We would like to start it, stop it, or restart it. On Windows it looks a bit different. And sometimes if you are logged in as administrator, or you have given it your user sufficient rights, you don't need sudo, and you can just start the MongoDB. Keep in mind that you have to use the D for daemon. And then once your server is up and running, which looks a bit like this. So I will start it like this, just with the mongod command. And we'll blurt out all kinds of messages, warnings, and status updates about your server. But the last one is the most important one, and it says waiting for connections on port, and then the default port for the mongol server. Just keep this tab open in your terminal if the command didn't close, because if you will break the command, then your server will shut down. So just open another tab, and in the other tab you can start the Mongol shell by just typing the Mongol. So in this way you can start the Mongol shell, and the Mongol shell is actually the same as our MySQL monitor, except now it's to use Mongo and not to use our MySQL. So it's a command line interface to interact with our Mongo databases. So the Mongo D is used to start your server. The Mongo is just used to start your Mongo shell. So as you would start your MySQL server, you would use the start command for your server. And if you would like to use the MySQL monitor, you would just use the MySQL command line. And once you've opened the Mongo shell, you will see that your prompt changes to this. And then you can start with your commands just by typing. For example, the help shows you all the options available. So in MongoDB, we have databases and collections. And as mentioned before, MongoDB uses a JSON-like format, and it's actually BSON documents. And they are stored in collections, and collections are stored in databases. So collections are basically equivalent to our tables in our MySQL. And to select a database in our Mongo shell, we just do the same as in MySQL. Just type in the use command, so use and then your database name. And don't worry about creating any databases. So if you would like to create a database, you can just use the use command and insert data in the database. It doesn't have to exist yet. If you execute the insert command, it will create a database for you.
When we try MongoDB, it gives a failure that we just do Mongo, it works, you know why?
Maybe the server starts up by default on your system if you done so in your installation. Could be like that. If it doesn't work, the Mongo command, make sure to check if your server is started, and if not started, then the Mongo shells should work. So, and then in our database, we can also have collections. And again, if we would like to insert data in our collections, our collection does not have to exist yet. Just insert or try to insert data, and MongoDB will create the collection for you. Keep in mind that when using a database, here you should use your own name for your database. So this could be anything actually. And this query, we'll come back on this later, will always be db dot and then the name of your collection and then a method. Inside this collection, we have records, and records are documents in MongoDB. And as mentioned before, these are field and value types. And the values of a field may include other documents, arrays, arrays of documents, documents of arrays, and so on. And the advantage of these documents is that they are similar to other programming languages. That's because of the usage of the JSON-like format. And there's less need for joins. And of course, the major one is their polymorphism. So no two records need to have the same structure. If we look into our data types more in detail, we will see that a typical Mongo document looks like this, with as first field the _ID field, then some other fields. For example, here we have a embedded document which holds again key value pairs. We have the type date. You can also have an array of values, square brackets, and you also have other types, for example, number long, which can hold numeric values. Of course, field names in Mongo will have some restrictions on them. So, as you could see from the previous slide, the _ID field is a fixed field which will be in each record of your database, and it's reserved to use for the primary key. So the value must be unique in every record or in every collection, and it may be any type except for an array. Other restrictions on the field names are that they cannot start with a $sign, because the $sign is used for other purposes in Mongo. The same goes for the dot character, so they cannot contain the dot character and they cannot contain the null character, which is actually quite, I would not say impossible to do, but quite weird to do so in your field names in Root. So why can we not use a dot character in our field names? Well, this is because MongoDB actually uses the dot notation to access elements in an array or to access the fields of an embedded document. When doing so in arrays, it uses a zero-based index, and when doing so in embedded documents, it just uses the field names. So for example, if we would, in this document, would like to return our first name from this person, we would do in our query name dot first, and then this will return our first name. If we would like to use a dot notation in an array, for example here the contributions, and we would like to get out the Turing test, we would use contribs dot and then 0, 1. Alright, this is quite important when using find queries. So keep in mind that arrays use zero-based index and that for embedded documents you can just use the field names. As mentioned before, the _ID will contain the primary key, and MongoDB will create one for you by default. It will be an object ID type, and it will always be the first field in your document, and if it's not the case, then MongoDB will move it to the beginning of your document itself. And again, this field may contain values of any data type other than an array. Some other data types are the object ID. This one is used for the primary key, but you can also use it in other fields. Then of course we have our strings, which are just characters in our database. You can have a timestamp. This is mostly used for internal MongoDB usage. Then you have your date type, which is in milliseconds since the Unix epoch, so since January 1st of 1970, so you always have to calculate the date if you use timestamp. But yeah, it's not used that often. And if we go back to our Mongo shell, you will see that you can perform some basic commands already. For example, to see all databases on your server, just type in show databases, so DBS, and it will print out a list of all databases available to you. So if I can show DBS, you can see that I have an admin database, a config database, a local one, and a test one already. So for if you just started with a fresh install, most likely the test database will not be in there. And you can carry out the other commands as well. So if you would like some help on the methods you can perform on your database, just type in db.help. And the help command goes for all methods on your database. So you can use it directly on your database, you can use it on your collection object, or you can use it on a method, and it will print out the appropriate help for the methods collection database. The same way you can show your databases, you can show your collections as well. And as we've seen in MySQL, sometimes it can come in quite handy to optimize your queries. We've seen indexes and views in MySQL. Well, our NoSQL systems, or MongoDB in this case, also has some types of query optimization. You can also create an index, but you can also use query selectivity, which means that the more selective you are in your query, the less documents you return to the user, so it will be faster. You can use a covered query where all fields you are searching for are in your index, so its database is capable of using the index in the most optimal way. And you can also limit the number of your query results, the same as in MySQL, just using the limit method in this case. So if you only ask for 10 records instead of 1 million, of course, it reduces your network demand and it will be a lot faster. And you can use query projections to only return your necessary data. So if you're just looking for the first name, for example, just return the first name and not the last name and the address as well of the person. This will speed up things quite a lot. Going back to our actual queries, so to create new data in our database, we can use the insert method, but you can also use the insert one and the insert many method. Keep in mind that the insert method can do both. Insert one can only insert one document in your collection. Insert many can only insert a typical insert query will look like this. So here in our case, inside my database, which is selected beforehand, inside the collection users, I will insert a new document, and my document will always be between curly brackets, will look like this. So I will add a new user with the name Sue of this age and the status name. If I would like to insert more than one document at the same time, I can use the insert or the insert many command. But keep in mind that my documents, so these ones, will have to be between square brackets, so in the form of an array. This is not necessary in the insert command when just inserting one document. So what does the insert command do? Well, it creates the collection if it does not exist already. And as mentioned, insert one can only insert a single document, insert many, insert multiple documents, and insert into both. So if you would do this in your database, you can always use test to use or to create a new database, and then just do in your database create a users collection, and then insert, and then inside your insert method there should be curly brackets for one record, and then you can just enter your name. And in the same way, you can also enter your age, like this, for example, and your like so. And if you then press enter, you will see, or you should see, like this, number of inserted records, 1, so I inserted 1 record. And as mentioned before, if I would like to do more records, then I will need the curly brackets to create an array. And then, of course, between my second pair of curly brackets, I will create another document. And then I have an array of 2 documents, or more, if you'd like to do so. And then it will insert these at the same time. Alright. So once we've inserted some data, we would also like to retrieve this data from our collection. We can do so by using the find command. This will be one of the commands we use most often. And the same as the insert one, find also has a find one if you're just interested in one document. Most of the time we will use the normal find command. And again, our query looks something like this, where we do on our database, so in our case, for example, test. Inside our user collection, we would like to find some results. And then we start specifying what we want to find. So our query criteria are between the first pair of curly brackets, and then between the second pair of curly brackets is our query object. So which of the fields and their values would we like to read. And then at the end of our cursor of our method, we can also add a cursor modifier. In this case, we're only interested in 5 results, so we will limit the query to 5 results. So the find method actually returns a cursor to the matching document. What does this mean? Well, a cursor can be iterated, so you can move through your cursor and find result per result, or do an action on each and every result. And we can have optional fields as mentioned, so a query filter and a query projection, and if wanted, a cursor modifier. So how do these query filters look like? Well, you can specify that a field has to have an exact value, so an equality condition, where you just between your first pair of curly brackets enter one or more key value pairs. So for example, I would like all persons that are male. I could just enter here sex double points equals male. You can also use query operators to do so, where you express your field and then your operators, or you can use some other conditions. By default, Mongo, if you would enter them in this manner, uses an AND between your conditions, so it's always both or multiple or all the conditions that are kept in mind. If you would like to specify an or between your conditions, then you will have to do so explicitly by using the or query operator. So where you specify $or, and this is of course the reason why you cannot have or start your field names with a dollar sign, and then your field value pairs. So in this case, for the last query, we will search for data in our database, which has or this field with a certain value, or this field with a certain value. Alright, and of course next to our or, we have a wide variety of query operators which we can use to compare values. What would they be as these operators already built in. The structure is always written on top, so you have your field and then your operator and then your value in this case for these values. So we can have an equals to, which is basically the same as just using the field double point value. This is only used if you have more or if you want to elaborate your query a bit more. And we have greater than or equals to, less than or equals to, and not equals, to specify an equality. And if you want to search in arrays, then our query structure will look a bit different. So we will have our field, then our operator, and then our array, of course. So we can search for values in an array with our in, and if we want to specify that, or search for values that are not specified in an array, we can use the not in. Next to these comparison query operators, we also have logical query operators. The or, as mentioned before, to specify an or condition, of course, between your clauses. The and, which is used by default, but you can specify it if you want to even more. The not or, and then the not, which has a different structure. So here you will use only your operator expression, so not in an array, as you will do for your or and not or. And then we can also check if an element exists or is present in a document using the exists query operator. Again, the same structure as before, only now it doesn't use a value, but it uses a boolean. So this will, for example, be field and then exist, and then this will be a 0 or a 1. 0 meaning it is present, not present, 1 meaning it's present. And then we still have some query operators which are only used on arrays. So you can search for an array in your document that contains all elements specified in the query using the all query operator, where the structure looks like this. So we have our field, our all operator, and then an array with one or more values. The element match query operator is used to find documents where the element in the array field matches all the specified element match conditions. So you can search for a field using your element match operator, and then you can specify even more, further your conditions inside your element match queries. And of course, you can also search for a array with a certain size using the size operator. Alright, so if you go back to your default query, these are always in your query criteria. So this is the first part of our find query we've been elaborating so far. So here you can see, for example, that all persons older than 18. For all persons older than 18, it will return a name and an address. And it will, of course, limit the results to 5. Looking more into detail to our query projection. So our query projection is basically saying which fields do I want in my cursor. So which data points should, which data fields should my database return. The same as selecting a certain amount of columns in your MySQL database. And your query projection will always look like this. So again, between curly brackets, key value pairs, but where the key is your field name, and where the value is again a Boolean value, where 1 or true and 0 or false. So if you would like to return all fields except for 1, you will use in your query projection the name of the field you don't want to return and use a 0 for value. Alright, keep in mind that if you do not specify it explicitly, MongoDB will always return the _ID field. And then we have some projection operations as well, where we use the $sign to just return the first element in an array that matches our condition. So our query will look like this. So we will perform a find. This is our query filter with our query operators if need be. And then our query projection, we will use an array and a dot notation to return only the first element. You can use an element match on your array or in your query projection as well. Keep in mind that this is not the same as the element match used in your query as a query operator, because this will return only the first element in your array that matches all the specified element match conditions. Alright, then going back to our entire query. So now we've seen our query criteria, our query projection, but we also have the part of the cursor modifier, which is optional, but you can add it if you want. And again, Mongo already has made some methods for us that modify the cursor that is executed. So in order to sort your results, you can use the sort method, specify your direction. You can use a count to count the number of documents returned. Has next or just checks if there are more results in our cursor to be iterated. Next just skips to the next result if you're iterating your query. To limit the number of documents returned, you can use limit. You can also use limit in combination with a skip, the same as the limit and the offset in MySQL. And you can ask for the size of a record by using the size method. And then maybe we should do, or I should do the first two, for example, maybe the first three, where if you entered these in your database, you can just open the text file and execute this in your Mongo shell, if you would like to do so, or you can use the Mongo import command, which is available for you as well. But if you've done so, inside your users tables, so if you did not specify your database, do it again. So to select all documents in my table, I can just do it like this, and this will return all documents inside my table. And as I can see, I have 1, 2, 3, 4, 5 documents already in there. In my case, this can be different for you depending on how many inserts you've done before you check this. So now we're looking for all documents where the status field has the value A. Well, then our query will look like this. So again, on our database, in the collection users, we will use the find method. And then if we would like to specify some query criteria, it's done between curly brackets. And in this case, we're looking for the field status that has to equal A. So if you look at one document, status is in there. It's not in an array or anything like that. So it's just a normal field. So status will have to equal A. Keep in mind that when you're using a string value or a character string value, you have to place it between brackets, the same as we did in MySQL. So if I now perform this, I will only return all documents in my collection where the status is A. So for the last two, or for the last one, for example, I did not have any status, so it's not included. Then the next one, select all documents in the collection where the status equals A and either age is less than 30 or type equals 1. So now we're going to have to use an OR query. So again, we can start with our status that needs to be A and either. So we will use the OR. And or, if you look back in the slides, you will see that you need an array for this. So the age should be less than 30 or the type should equal 1. So again, specify your criteria between curly brackets. So age should be less than 30. Like this. So now I've specified my query where the status needs to equal A and the age needs to be less than 30. And of course, we need a second criteria inside of or type should equal. So as you can see, when using these type of JSON-like documents, you will need a lot of brackets inside your query. So now I've created my query on my users collection, where I will look for users that have a status A, or the age should be less than 30, or type should be 1. And this again gives us some results. So status is always A for these. Then if we look at the age, it should be less than 30, so for the last two, this is already okay, or type should be 1. So this one is older than 30, but the type is 1, so it's still correct. Alright, and in the same manner, you can try to do the other exercises. If you have any questions regarding these ones, just mention it on the forum and I will help you out, or you can help each other out. Alright. So far we've created a new collection, we've inserted some data, and we've retrieved the data from our collection. And if we want to update a existing document in a collection, we can use the update method. Again, there's an update one and update many available for you. And there's also a replace one method available. The difference between the update and the replace is that the replace replaces the entire document, and the update just updates the fields you specified. So if you look at an example for the update query, again on our database and collection users, use the update method, specify some criteria, so we will only update the users that are older than 18. And for these users, we will set our status to A. We're using again an update operator, set 6 to A. I will use the multi is true to update more than one record when using the default update method. So as you can see from this example, we will use update operators in a similar way as we used query operators. And again, Mongo already made some update operators available for us. So, for example, the increment, which just increments the value of a field you've specified by a certain amount. So, for example, say that every user with his age is in there, and you want to make everybody 5 years older. Just use the increment on the age, and then for amount choose 5. In your update query, and every user inside your database will be 5 years old. Some other update operators available for you are set, add to set, pop, pull, and push. These will work in a similar way. So set, as we've seen from the example, will just set the value of a field inside a document. Add to set will add an element to an array only if they are not already in this set of values. Pop removes the first or the last item of the array, depending on the parameters to give it. Pull removes all array elements that match the criteria you set for it. And push just adds an element to an array. So if you, in your update query, would like to add an element to an array, just use the standard type, so use some criteria. If you would not like to do it on all records, here you can use the push and then of course your key value pair. Alright. So for example, if we would like to replace the first document matches the filter name equals, so the last exercise in this part, you can just copy it from the slides, the new value. And then your query will look like this. So on your database, in the users column, we will update a field, and then between curly brackets, all our specifications. So in this case, the name should equal X, Y, Z. And it should be replaced, but we're using an update query here. You can also use replace one and use the same filter, and then a comma, and then you can just paste the part from the slides. So this is the this entire document. And with this query, you will update all users named XYZ. The entire record will change to this. So the name will change, the age will change, and so on and so on. I think if I will do it, it won't do anything because I already executed this query. So it didn't match any records, it didn't update anyone or any records, or it didn't modify any records. In your case, if you're performing this for the first time, this should say 1, and one of these should say 1 as well. Alright? Again, try the other ones yourself and just contact me in case of any problems. So after inserting, creating, reading and updating our data, of course we would sometimes also like to delete data from our database. And this is one of the most easy commands, it's just the remove command. Again, there's a delete one and a delete many option available for you. So your query will look something like this. So in your database, the users collection, you would like to remove something, and if you don't like to remove all documents at once, please use a one or more remove criteria. So in this case, we will remove all records with status D. Executed, and your database will look a lot different. So again, you can try these yourself. They're basically the same as this example. Keep in mind that again, you're free to choose whichever command from these you want. You don't have to know every query in 3 different ways. And if we then compare our MongoDB to our SQL systems, we know from the previous lessons, so a database is still a database. A table from MySQL or from SQL is now a collection, and data isn't stored in rows any longer, but in documents. So rows in our SQL system had a fixed structure, where our documents can have a different structure for each document. Inside these rows we had columns, now we have fields in our documents. An index is still an index, and a primary key is also the same. And instead of using joins to join different tables, we just use embedded documents. And as mentioned in the beginning of this lesson, as we did in MySQL for aggregation, MongoDB also allows for some aggregation with the aggregate method. This is quite elaborate, but can come in quite handy if you're using different or difficult queries. So a typical example in SQL could look like this. So remember, we've selected some columns, and we did some aggregation function on this to calculate, for example, the combined population per state. In order to do so, we had to group in MySQL, and then use a filter on our grouped results, so with our having instead of our where. And this is the same as this query in MongoDB. So on our database, in our zip codes collection in this case, we would like to aggregate some data, and then between the brackets, you will always have a array of actions you would like to perform. So use a square brackets for this, and then we would first like to group our records in our database, where we will create a new underscore ID table, and our new underscore ID will be state. So this is basically saying the same as group your results by state. And then your total population should be the sum, so that saying the same as here, we would like to calculate the sum of all populations. And here you will say calculate the sum of your populations. Small remark here is that when you're using a field that is already in your database, keep in mind that you will have to use the $sign in front of your field name between your quotes. And then the having part of this query translates to a match part in MongoDB, we will search for the total population, which we just calculated here with the sum of our population. It has to be greater than or equals to, and then just the same calculation as we did here. Alright? So now we've seen group and match, but of course there are many other aggregation pipeline operators. You can use a sum, you can calculate an average, you can use a limit, skip, sort, concatenate, and so on, and so on. So if we would like to test these aggregation queries, you can always import the JSON document that is on Lego with the Mongo import command. Keep in mind that this command should be executed from your terminal and not from within your Mongo shell, of course. And if you've done so, you will have a new collection in your database. And then we can, for example, return the average city population by state. So inside your database, there should be a zips collection now. And we will aggregate on this collection. So always normal brackets and then square brackets, and then we can start. So the average city population by state will mean that we will have to group by state. So our first aggregation operator will be group. And then we'll create a new ID or underscore ID column, which will be a combination of our state and our city. Why is this? Because we want the average city population by state and not the average state population. So in this case, our ID will be a combined ID, where we will use the state and the city. So now I've grouped my results, created a new underscore ID, which will be, of course, extra brackets, state and city, the combination. Yes. Then we would like some other fields, so I will calculate the population and put it in a new field called pop in my case. We'll use a sum for this, and we'll calculate the sum of all existing populations. And then just another bracket like this. And then our group part is already done for the first part of our query. And then, of course, now we've calculated the population for each city-state combination. We want the average city population per state. So we will have to use another aggregation operator. This will be group again. So we will group a second time. Only this time our new ID will be something different. So it will be our state part of our ID that we've created before. So this is why we're using the $sign. And the dot notation, because this is a combined key, so in an embedded document, dot notation will be id.state or id.city. In our case, we will use the id.state. And then We'll also need the average city population. Alright, so the average city population, which I will want to calculate. And my average city population will be this. So the average of my population, which I've calculated here. Alright, and then just the right amount of brackets. Yes, and then a square. And then this will blurt out the average city population per state. So the cursor will only return a certain amount of documents. If you do not specify the limit method, you can also use IT or type in IT to show more of your results. Alright, and then you can try the second example yourself. Again, questions, post them on the forum or just ask me.
I only get 3 points after exclude.
Perhaps there will be a misplacement of the brackets. Will be most likely, or your import will not have been executed entirely. So the position of your brackets is quite important, and also the usage of the quotes and the dollar signs on the right spots.
Why don't you use Mongo import from the shell?
Because the Mongo import command is a command doing the same as, for example, starting up your Mongo. It's the same as we did with MySQL. You can also use MySQL import command from the terminal. And it's basically calling a Mongo instance, importing it, and closing it down again. If you would use the Mongo import command from the shell, would not recognize it as a command, and it will fail. So far we've been using the Mongo shell, and as we did for our MySQL monitor, by switching to the MySQL workbench, you can also switch to a graphical user interface for MongoDB, which will be a lot more handy when typing in all those brackets. And there are some options available. You have MongoDB Compass and Robo3T are the most spread versions. And I would suggest, if you would like to experience a graphical user interface, you install the Robo3T just Google Robo 3T and you will find the version for your operating system. Install it and it will look something like this. Yes. It will pop up something like this. You will not have any collections, so you can create one over here. Just press create. Give it a name. In your case, it can be localhost because your server is on your localhost. Do not change anything here, so address can be localhost. This is the default port. Just press save or test, and then you can just double click it to connect with it. And if everything goes according to plan, and it opens up like this, you have a welcome page, and you have your database here. So in our case, our test database with your collections, and you have, for example, your users collection. If you double click it, it just performs a find query on it, and you can see all your documents. You can open up your document to search for results or to more into detail. And you can execute queries here at the top, as you did in your MySQL shell, in your Mongo shell. Just print or type in your command and print the play button at the top, and it will execute commands for you.
Just use Mongo shell.
It's based on your own preference. If you would like to use the Mongo shell, it's fine. If you like rather use this, it's also fine. This can be a bit more handy to type in all the brackets because you don't need your so you can place your cursor where you want with your mouse. In the terminal, that's quite difficult to do so. All right. So that were our NoSQL databases. Let's switch to the online databases, because of course not all data will be in databases we create ourselves or we host ourselves. So therefore there are some online databases available for you in bioinformatics or in the field of bioinformatics. And why is this? Well, to make data available to scientists, but also to make data available in computer-readable form. So when scripting something or when performing a statistical analysis, you will need your data in a certain format, and these databases provide this for you. The online databases are divided into different types based on several properties. So the type of data can be important, the manner of data entry or the quality control. Does the database contain primary or derived data? What is the technical design of a database? What's the maintainer status and what's the availability of the database? So if you look more into detail to this, the type of data can be all sorts of sequences, nucleotide, protein, and so on. If you look to the data entry and the quality control, data can be deposited directly, or a database can have appointed curators that add and update data. What does your database do with wrong data in your database? Is it just marked or is it removed? And so on, and so on. Does your database contain primary or derived data? Well, main difference is that primary databases just contain experimental results, and your secondary databases contain the results of an analysis on these primary data sets. But you can have an aggregate of many databases as well. So it's just a matter of in which way they consolidate your data or combine different data sets from different analyses. The technical design of your database can be important as well. Does it store your data in flat files? Does it use a relational database? Or does it use an object-oriented database like an OSQL system, for example? And then you also have your maintainer status. Is this database hosted by a large public institution, or is it just one scientist or one academic group that is hosting your database, or a commercial company, for example? And this leads us to the availability of your database. So it can be publicly available without restrictions, or it can have some copyright restrictions. But it can also be a commercial database, or it can just be an academic database, which is only free for researchers, for example. But all of these databases, no matter the type or the way of storing data, use a similar way of identifying entries in the database with identifiers and accession codes. And these identifiers can usually change inside a database, and they're most of the time just strings of letters or digits in an understandable form. For example, a microRNA can have a certain name, and this can be used as an identifier, which can change later on, but the accession code that is linked to the same microRNA is stable. So even when your database changes or your identifier changes, you can always find your same record back based on your accession code. If you look more into detail to some databases, for example, the primary nucleotide sequence databases, you will see that you'll have three main ones: EMBL, the GenBank, and the database of Japan. They do little or no error checking, and they contain a lot of redundancy. But luckily for us, they're synchronized on a daily basis, so no matter which of the three you query, you should be able to find the same results. There are no legal restrictions on the uses of these databases, so you are free to do with the data inside whatever you want. So the EMBL part of the database contains DNA and RNA sequences, and it has three databases inside the large database: the sequence read archive, trace archive, and then the nucleotide sequence database from EMBL. And they're maintained by the EBI, so this is a large institute. And they store data in different formats, so you can query your data and ask for it in XML, HTML, fast or FASTQ format. And all this data is available through their website, where you can just query it without any knowledge of a database query language. GenBank, one of the other main databases, is also open access. Main advantage is that it has quite a lot of different organisms, and this is also maintained by a large institute. And you can retrieve data directly from their webpage or from their FTP server. GenBank created their own format, which is basically a flat file with three main sections. You have the header section if you go to a GenBank result, which contains some general information. Then you have the features section, which contains more specific information about your sequence, and then you have your sequence itself. And the last one is the DNA data bank of Japan. It only contains DNA sequences, and it's the only nucleotide sequence database in Asia. Again, you can access results from their database or records from the database through their webpage. Maybe they do, but it's not publicly available. And then moving on to our secondary nucleotide sequence databases. So these are databases that contain results based on an analysis performed on these primary nucleotide sequence databases. And there you have your RefSec, OMIM, HapMap, which all contain a specific type of data. If we look more to other nucleic acid databases, you will have distinct databases that contain gene expression data, gene ontology, or just genomes entirely. We also have phenotype databases, and now more than often there are some RNA specific databases available as well. Then we have some sequencing databases as well. These contain, as the name states, only datasets from sequencing experiments. You have the Sequence Read archive. You also have the European Genome Phenome archive. Only downside for the last one is that the data is not publicly available. Some of the most important protein databases, which contain protein sequences or protein structure, are mentioned here. So for protein sequences, most used, or one of the most used is SwissProt, or the NCBI protein database. And if you're more interested in the structure of your proteins, then you can just query NCBI structure instead of NCBI protein, or the protein data bank. On most of these databases, you can you can retrieve your data in a GFF format, which is a general feature format. And this format is a standardized format which is quite often used. It's basically a tab delimited file with one line per feature. It has some fixed columns, and it has some additional information as well in there. So a general feature format file looks like this, where I'm not sure if you can see it here. So the first lines are actually commented out with hashtags, and these contain just the version information and some general information. And then the features start, and then for each column you will have a certain feature, which is mentioned here. Should not know this by heart, but keep in mind that all these data columns should be in there. And then of course there are also some websites or web tools that present their data, or their data in a graphical manner. You have genome browsers, for example. Two main ones are the UCSC genome browser and the Ensemble genome browser. And they just translate the textual data to a more graphical approach. Based on these databases, try to find the answer to these questions in the database most convenient or most suited for this question. But we'll have to move on. Just again, if you encounter any problems, contact me or raise it on the forum. So many of these databases are also available in your MySQL directly. For example, UCSC or Gene Ontology and even Ensemble provides connection parameters for their databases. So if you would like to test these, you can just use your MySQL command as you did in the first lessons to connect, but instead of connecting to your local host, your host will now be one of those. And you will connect as this user. For UCSC and Ensemble, you don't need any password. The Gene Ontology uses a password and different. If you look more into detail to the ensemble database, well, the ensemble database, you can query it directly in MySQL, but it has a quite complex database scheme, so it's not suited to retrieve sequences directly. So therefore, Ensemble created an API to use, so an application programming interface. And this is basically just a uniform method of access to the data. So it's reusable on different systems. It's very reliable because it shields the user from the database itself. And as mentioned, yeah, it insulates developers to the underlying database changes. The Ensemble API is available for you in a Perl API. Again, another programming language, of course. But if you're scripting a lot, then the API is quite more convenient than querying the database itself. You can find installation instructions for the Perl API on the Ensemble website if you are interested in installing it yourself. We don't need it for this course, so you're not obliged to do so. And you can have different versions based on the different Ensemble releases. The main setup for this Perl API is that you always use a registry to find the appropriate Ensemble database and connect to them. So again, here just loading the registry with a Perl module and then using the connection parameters. The Ensemble API can query all sorts of or several databases inside the Ensemble database system. The core database, the Compara database, the variation database, and the regulation database. They all have their own structure, and they look like this, for example. So the core looks quite simple compared to the other one. And if you would like to use the Perl API or the Ensemble API to query this, you will use your registry as mentioned in the previous slides. You will then create a slice for it. So for example, in this case, we will like to do the viewing, the core database, and we will create a slice. Then we will fetch all clones from this slice, and then perform some other actions on it. For example, to get all the genes of the clone. And you can see how you can create your entire program if you would like to do so by querying the Ensemble API. The Compara database looks a bit more difficult already. So again, you can use the Ensemble API to query this. This is a cross-species database, so it's used to compare data across different species, both on DNA sequence level as on gene. The variation database is even more complex, and this specifies on searching areas of the genome that differ between individual genomes, so variants, so to say. And you can have sequence variants or structural variants, both are. And the regulation database was the last main one from the Ensemble database. And this contains gene expression and its regulation both in human and in mouse. So it's not available for other organisms than human and mice. And of course, I can hear you think, okay, so if we want to use the Ensemble database and we don't want to query it directly, we will need to learn Perl, an entirely different programming language, in order to do so, and that is why Ensemble created another solution as well. So instead of using the Ensemble API, you can also use the Ensemble REST API. which stands for Representational State Transfer or RESTful API. And this is basically a web page where you can post or get data from, and it returns the data to you in a certain format. The REST API uses a base URL always, so you can just access it through rest.ensemble.org. And it's quite convenient because it's a language agnostic binding to the Ensemble database or to the Ensemble data, meaning that you don't need to know any programming language to do so, or to query it. You're able to create your own REST client if you would like to do so in each of these programming languages, but you do not need one to start using the Ensemble REST API. The basic URL structure will look something like this. So you have your server, you have your endpoint and your parameters, and then you can have some optional parameters as well. So you need 0 or more required parameters, you need 0 or more optional parameters. And in a standard URL, the required parameters are flagged with a double point. The optional parameters should go into the request body, so in this part, if you're performing a GET, and if you're performing a POST, of course, you should do so by using a form or something like that. The Ensemble REST API uses some parameters, as said before. So you have to specify what is required and the type of returned data as well. Some of the examples are ID, region, species, and so on. You can find them on the website of the REST API. They're all explained there with examples as well. And then you can retrieve your data in different formats. So you can ask the API to return your data in a JSON format. You can ask for a FASTA file, a BAT file, and so on. The output format, of course, depends on your client and on your operation. Most of the time, you will perform a GET operation, meaning that you will use the parameters from your URL. Sometimes you will use a POST if you would like to filter some results. Some of the endpoints, as mentioned before, so used in your query will look like this. So, for example, when performing the GET method, you will use your rest.ensemble.org and then slash and then archive slash ID, and then if it's stated with a double point and a value, then you should replace this with an actual value or an identifier in your. These are just some of the endpoints. If you need other ones, they're on the website from the REST API. Just know how to use these. So again, based on the type of query you would like to perform, there are some different endpoints for sequence, for variation, and so on, and so on. So now, how can we perform actions on this REST API? Well, you can always copy a URL in your web browser if you would like to do so. So, for example, for the first one, return the archive sequence with ensemble ID, and so on and so on. If you look at the ensemble REST API, we you can always paste your query in there. So we're looking for the archive sequence with ensemble ID, and then this ensemble ID, for example, just use rest.ensemble.org/ and then check your endpoints, which one you should use. In this case, archive, then an ID, and then I fill in my ID. So now I've chosen this one. You can also choose this one. So this will be something like this then, 4.15.0. And this will give you all the data available in the archive part for this item. Of course, this is okay for GET requests, but if you would like to do a POST request, then it's not that convenient through your browser. So in that case, we will use a terminal, and we will perform a curl request. So curl is a method for posting or getting your data to an URL, but on the command line. So it's just using the curl command, and then between brackets you will place your URL. So in our case, we will use this one. So for the first exercise, it was something like 4.1.1.0. And this will already work. Well, we can also specify that we want our data back in a certain data format. So we'll, in this case, I will ask for JSON format, like so. So I will perform a curl request on my URL, which I can retrieve with my endpoints, and then I will give it some additional headers with the -H option, and in this case, content type application JSON will return our data in JSON format. You can always check the different type of headers. You can pass it on the website itself, and as you can see, now my data, the same as the one presented to you on the web page, is returned inside a nice and clean JSON format. Alright, so this was for a GET request. Maybe I should do the second one. So return the archive sequences for both, and then 2 sequences. In this case, we can again use our curl command to return it. In JSON format. Only now, instead of posting or giving our ID directly with our query, we have 2 IDs, so we can't place both of them in there because the endpoint will not know which one to select. So we will define another header where we will say we will pass you some data, so accept data in JSON format, and then we will use our method post instead of the default get, so -X post. We'll define that we're using a post method, and then with the -D we will send our data. And in this case we will have IDs, 2 of them. It's in JSON format, so array, and inside this array we will have both values. You can just copy them. This. So now saying we want to request data from this URL, we will would like it returned in JSON format. Would like to send some data in JSON format as well with our post method, and our data looks like this. So this is a JSON string with our two IDs. This should already work. And now we get our results back in JSON format. And as you can see, it's an array with two results. So the first one being this up until here, and then the second one is over here. So now we've done the same as in the first exercise, only now we searched two ensemble IGs at the same time. And in the same fashion, if you select the correct endpoints, you can solve the other exercises as well. All right. And then the last part of our course will be some version control. So far we've created our databases and we've entered data in them, deleted them on both systems, so MySQL and NoSQL, and even online systems. But in most of the cases, you would like some version control, especially when creating your own database. And in order to do so, you can use a Git system, and this is a system used to track and store your revisions or your versions of your files. And it's very easy. You can install it on your Linux system. If it's not already installed by default, depending on your operating system or your Linux version. And if you install it, you can use the help command and the config command to configure it. We just first go over some commands. And in order to initialize a Git repository, it's as easy as going to a folder you want in your repository on your system and entering the command git init. It will create a repository from your current directory, and then you can ask for your status. The status will show if your files are already in the repository, if they're changed, if they're deleted, and so on and so on. If you want to track files in your repository, you will first have to add them to your repository. And if you've made some changes to your files, you will always have to commit them to your repository in order to let it know or save a version of these files. In order to keep some overview of these commits, you should always enter a commit message. So the command will be git commit and then -m and then between quotes your commit message. The commit message, the -m option is actually optional, so that's why it's between square brackets. But if you don't enter it right away, if you commit it on a terminal, it will open another monitor for you, and you will have to enter your commit message there. So it's best to just enter it straight away. In order to reset your changes, you can use the git reset command. In order to track your previous commits, you can also check the logs. And to check out a commit, so if you committed your files to your database, you also have to, you can also check it out on a different system. You can use the git checkout command and then the checksum of this specific commit. So let's say you've created a file, you have 10 versions of it, and you want to share a specific version of the file with a person. and he or she can do a git checkout of this version. To show the differences between two revisions, you can use the git diff command. If you don't use any checksums, it just shows the difference between the current one and the previous one. If you use checksums, you can check for differences between specific revisions. You can also use branches in Git. So stating that if you start one branch, so you always start one branch, your master branch, you have some files there, but you would like to collaborate with another person, but you don't want him to mess up your files. You can create a different branch for him, and he or she can then work on his files in his branch, and later on you can commit them to your branch again, and you can merge his files as well. In order to delete a branch, you can just use the git branch -d command, and all these repositories can, of course, instead of just saving them on your local system, can be linked to a public system, which is on GitHub. So if you go to the github.com web page, you can create a repository over there for free. Please do so at home. So register, the account is free, and try it out. To create a GitHub repository, there's an exercise on this over here. But first, in order to get more acquainted with Git itself, of course, because now I've only overloaded you with some commands, there's a graphical tutorial for this in the form of Git. So if you go to their website, Git has a specific website, and then you can download Git itself, and then I think if you start it and downloaded it, it will look something like this. So it has a version for Linux, for Windows, and for Mac as well. And then you can start the tutorial in the language of your preference, of course. I don't think Dutch is in there, so most likely be English. And this will guide you through the installation for Git and through some basic commands. So how to add your files to a Git repository, how to commit them, how to link them to a remote server, so the GitHub instance. So please follow at least the first part of the Git tutorial, so that you've seen all the commands that are in the slides. And please try out the exercise that is in there. You should be able to link your local repository to one on GitHub and to commit files today. So I will not go over this tutorial here step by step. You should do it on your own pace. And again, if you have difficulties with setting up your public GitHub repository or your local Git repository, don't hesitate to contact me or to start a discussion on the forum. This will be quite important for the exam as well. So basically, I think that was it for today. So a lot of information. For the exam, I'll make some rehearsal exercises available for you as well. And that's for the practical part of the exam. For the theoretical part, I think everything that is in the slides can be a theoretical question. I will not ask you to know certain SQL or Mongo queries by heart. This will be for the exercises part, but everything else in the slides can be a theoretical question. All right.
There will be an example exam.
Well, these rehearsal exercises are in the form of an example exam.
For the practical exam.
Yes. I think for the theoretical exam, there's, I don't know, but I think there's a example exam already on label somewhere. I should check. I'll check, and if it's not in there, please. Keep in mind that for the theoretical part, this is a closed book part. For the practical part, you can use your slides, the syllabus, and the internet, except not the other students, of course. All right, that's it. Yes, that's it.